So this right here, this is where most people lose. They scroll articles, they read threads, and they stay informed and build nothing. We're not doing that today. We're turning this into strategy execution systems because hidden inside these articles is the real signal. AI is not replacing engineers, it's replacing engineers who don't adapt. So moving into segment one here, let me go ahead and bring up the page. Now, the Claude code leak and the real takeaway, right? So everyone's talking about the Claude code leak. Now that's the wrong focus, right? The code doesn't matter. The strategy it does. Here's what was exposed. So anti-distillation tactics, so protecting models from being copied, undercover or stealth agent modes, product roadmap direction, and client attestation. So this is a trust and verification layer. So let's translate this, right? The AI war is not about intelligence anymore. It's about control, distribution, and defense. So this is big because if you're building AI products, you better be thinking about ownership, security, and moats, not just cool features. Moving on into segment two, Meta turned debugging into a product. So this one is elite. Meta built a system where debugging is codified, automated, version. 50,000 analysis per day. Let that hit. That means debugging is no longer reactive, it's a system. And here's the move for you. Stop fixing bugs manually. Start building debugging agents, monitoring systems, auto analysis pipelines, because this is where engineering is going. Engineers design systems, systems handle execution. Now, moving into our next section, React use hook and why this matters. So React just broke its own rules. The new use hook kills a lot of boilerplate. But here's the real lesson. Simplicity always wins long term. And also, abstractions are collapsing. Less code equals more power. But there's a catch. If architecture is sloppy, everything breaks. If your promises aren't stable, infinite loops. So translation, the better the tools get, the more discipline matters. This is why senior engineers still win. Now, moving on to encoding team standards. Now, this is something that is very huge, right? So pay attention. This might be the most important insight that we talk about today. So AI output quality depends on who is prompting. And guess what? Most people are bad at prompting. So what is the solution? Encode standards into the system. So this means repo level AI instructions, versioned prompting systems, built-in architecture constraints. So this is exactly what we've been saying. Your moat is not the AI, your moat is your system. So you want to be building a system for how you utilize AI, a strategy, right? So it's more important how you're using AI right now. It goes beyond prompt engineering. Moving on. AI agent-driven development and Copilot applied science. So agent-driven development is real execution. So this is very crazy, right? 4 engineers, 3 days, and 11 agents built 29,000 lines of code. How? They treated agents like junior engineers. This is a mindset shift. So they gave clear instructions, enforced structure, reviewed outputs, and iterated fast. So if you're just chatting with AI, you're doing it wrong. You should be managing a team of agents, right? Moving on. So tools and launches and what to pay attention to. So let's move a little bit faster here. So Claude Code. People are already rebuilding leaked systems. That tells you that speed over originality, execution over secrecy. Sugar high. Even small tools matter if they solve real pain, right? And the job listing that we passed and I didn't even touch on, $250,000 to $350,000 for AI engineers. You still think this is hype? And I'm actually going to apply to this. This is a new team that TLDR is actually creating. Now, moving on. North Korean hackers hit a JavaScript library. That's not random, that's strategic. Here's the takeaway. Your dependencies are attack surfaces, and your stack is only as secure as its weakest link. So if you're building serious systems, security is not optional ever. Now, monospace. So fonts sound pretty boring, right? Wrong. This is about the developer experience, readability, and performance of thought. So texture healing, quote unquote, equals better code readability, and better readability equals faster development, fewer bugs, and better systems. The details matter. I wrote a book called The Art of Reading Code, so you can already kind of tell what my stance is going to be on something like this. Readability is something that's very important, and often overlooked because documentation is something that's overlooked as it pertains to development, right, and coding. Moving on. So these are some of the quick hits. You don't want to ignore these, right? So we're going to rapid fire these really quickly. OpenAI raising insane funding equals AI dominance race accelerating, right? PG tech search equals better search, which equals better products. So forgotten code intent, this is exactly why systems break, all right? Flaky test, usually infrastructure issues, not logic, all right? So translation, most dev problems are system problems, not code problems. Let me say that again. Most dev problems are system problems, not code problems. In closing, let's be real. The entire breakdown points to one shift. Engineers are becoming system architects, not coders, not button clickers, not framework experts. You either build systems or get replaced by them. And the window, it's open right now, not next year, not later, now. So final questions for the chat. So what systems are you building instead of coding manually? Where are you still acting like a solo dev instead of a system operator? What are you automating this week? And just to give you guys some more context, at the beginning of 2025, I said automation was something that I wanted to focus on because I knew it was coming. I knew agentic AI was coming. I knew automation was coming. I knew using computers and using our devices in a way that we never have before was coming. So I wanted to be ahead. I wanted to start automating my content creation. I wanted to start automating because that's where everything is going. The only people who are going to be actually still using their devices, like having it in their hand and not talking to it or not prompting it, like you're going to be left behind because you're still manually doing so much. And the rest of us are, like I said, the rest of us are busy living life while, we have agentic AI doing a lot of the heavy lifting for us. So with that being said, I'll leave it there. Thank you guys for tuning in. Make sure you guys follow the channel and subscribe, and have a great day and keep coding. Or actually, hold on. We got a few things to show you guys. I always try and prematurely end the stream. So let's jump back in here really quickly. Let me close some of my tabs here. Okay, now I wanted to talk to you guys about how exactly do I use Codex and Claude, because I see a lot of people using Claude Code and they're like, oh, Codex sucks. The thing is, you don't know what you're doing. I mean, I'll just put it simply. I'm not going to be nice about it. You don't know what you're doing. You don't have a clue, right? You just think that AI is magic and like, oh, I'm going to put this in and then have it do something for me and get the right result. No, you don't know how to use it. So anyways, that's why a lot of you are going to have Claude Code. It has a lot of you by the balls as well, because a lot of you are paying for this. Is like as soon as they raise the prices up, a lot of you guys are going to be like, man, like by the balls, because Claude Code is doing everything for you because you don't know how to use AI. You don't know how to diversify your tools, your tool usage, right? You use Claude Code and that's it, right? So let me show you. This is a stack that is pretty much Codex as a primary builder, Claude Code as a reviewer, debugger, planner, repo surgeon, Cursor as the control center and not the brain, because Cursor still allows you to use it for free, right? Minimal usage, right? So that's why I still use Cursor as the IDE. So if you guys want to use this, please go ahead, because I mean, somebody has to teach you kids how to actually use AI, right? So no problem, right? And this is, like I said, this is my exact setup. This is my exact how I use AI today. This is my exact setup. So I'm giving you guys, I'm giving you guys my sauce, right? And I'm going to change it up after this, right? Because I'm not going to keep doing the same thing. But this is exactly how I use AI today in real time. So core stack, core rule, treat your stack like this: Codex, primary builder; Claude Code, reviewer, debugger, planner, and repo surgeon. Cursor is the control center and not the brain. So Codex is built to work in Cursor or VS Code forks and can use IDE context, local changes, cloud task, and multi-agent workflows, right? So OpenAI also now offers GPT-5 Codex Mini and prompts you to switch when you reach 90% of your 5-hour Codex usage window, specifically to extend usage. Claude Code is strongest when you use its persistent shell tooling, auto memory hooks, and reusable skills instead of treating it like a generic chatbot and terminal. So the operating system for my workflow is this. It uses a 3-lane system. So lane 1, cheap, repetitive local edits. We're going to use Cursor, native lightweight flows, or Codex Mini for these things right here. Renames, simple UI tweaks, boilerplate, small refactors, copy changes across similar files, tiny bug fixes, test generation, and doc updates. Why? OpenAI says Codex Mini gives up 4 times more usage than full GPT-5 Codex and is explicitly there to stretch your subscription window. So what does this mean? This means that if you're not being efficient with how you're utilizing the different models in code, because I pay for ChatGPT, right? I've been paying for ChatGPT because I use it for its image generation. I use it for as an assistant. I use it for its GPTs. It was one of the first AI subscriptions that I was paying for before I started getting into coding heavily, because there was no IDE, there was no Cursor, there was no Claude Code, right? So I was literally using ChatGPT, and like I was at work before all of this was even in fruition. Like, this is 2024, end of 2024. I was at work at my job giving ChatGPT context about what I had, about features I had to build in my job, and building out full features using ChatGPT before you could ever even have Claude Code. This is what I'm saying. I've been using AI, but when people were still like being quiet about it, like shh, when people that were at work using AI, even though they weren't supposed to be probably, and we're still using it. I was one of those people. So because I knew where it was going, I wasn't gonna slow myself down because corporate didn't exactly know how they wanted to, integrate AI. I was like, fuck that. I'm using AI, like, right? So I had AI, I had ChatGPT open on my other MacBook, and on my work machine, I'll just be going back and forth. I'm pretty much anything that I need to transfer over, I would just copy it over, by hand, because I've typed pretty fast. So, anyways, so you want to be I had a system for how I use AI even back then. You know what I mean? So you want to have a system for how you're using AI. You don't want to just be randomly typing shit into a chat and thinking that it's going to do what you tell it to do, even when you have it, like, even when it has all of the context. Like, that's not how it works. You have to learn how it works and what it's good for, what it's bad at, and what it's bad at. You got to understand how to give it more context and more rules, and so it can become good at the things that it's bad at. So this is about getting better at using AI. If you're not getting better with how you use AI, then eventually you're going to be shut out. But that's another conversation. So let's go into lane 2. So the mainline feature work, right? So we're going to use Codex Standard as the main Codex flow, right? So this is going to be for implementing scoped features, multi-file changes, code gen that needs local editor context, task you want to apply directly in your working tree, task that benefit from cursor selection, plus open files context. So why? The IDE extension is designed for Cursor, VS Code forks, and works best when it can see your open files and selection, which lets you use shorter prompts and get faster results. So obviously, right, we use it inside of an IDE because we wanted to be able to have access to all of the context. That is the whole point, because I was copy and pasting, sometimes entire code files into ChatGPT when I was trying to give it context for what we were trying to do, right? Or especially when we're trying to fix bugs. So copy and pasting errors, things like that. And this is, like I said, this is before I think it could even accept screenshots the way it can now. So now lane 3, this is high risk, high ambiguity, and deep debugging. So use Claude Code for root cause debugging. So I only really use Claude Code for very heavy stuff. So root cause debugging when we have a serious error. Why this architecture is failing: repo audits, tracing weird side effects, terminal heavy diagnosis, migration planning, alternative implementation strategies, and quality review before merge. So why? Claude Code's docs emphasize shell commands, hooks, reusable skills, and memory across sessions. That makes it especially good for repo understanding, deterministic checks, and repeated engineering rituals. So the biggest mistake to stop making, guys, let me now. So you want to pay attention here. The biggest mistake to stop making when it comes to AI is do not ask both tools to solve the same broad task from scratch. That's limit suicide. So this is bad. These are bad habits you want to stop doing, right? Build the entire onboarding flow. Stop asking. So stop having just putting that into your input directly, and then asking Codex, and then asking Claude Code, and then asking Cursor Chat, and then pasting all outputs back and forth. Now that's cool if you want to compare, right? And you have the money to do that. You have the token allotment to be able to just go and do that because you're conducting research. Sure. But if you're trying to build something, or if you're a founder and you're like, your money is you need to get efficiency for your money, don't waste it doing that, right? A good way to use, if you're using multiple models like I am, a good way to think about it or to utilize them is this, right? Codex builds, Claude audits, Codex patches, Claude verifies edge cases. So this is how you multiply output without wasting. Okay, so the best routing strategy is going to be this. So this is exactly what I use. So you can copy exactly how I use AI today, right? Codex, Claude Code, Cursor, IDE. This is exactly how I use AI. So use Codex first. When you already know what you want built, the scope is concrete, you want edits applied, the task is implementation heavy, you can point to exact files and components. So the prompt shape, right, is you have an objectives, you have the files involved, constraints, acceptance criteria, and what not to touch. So these are all the things that you need in place when you use Codex. Okay, so then as an example, here's an example prompt pretty much. So add default avatar fallback for drivers in the feed. Only touch feed card rendering and shared image helper if needed. Do not change API shapes. Preserve current layout acceptance. Broken image URLs render a default placeholder cleanly on web and iOS card views. So that kind of prompt is lean, surgical, and cheap. And so you want to use Claude Code first when you don't trust the diagnosis yet. The bug is slippery. The repo behavior feels systemic. You need a plan, not code vomit. And terminal tooling inspection matters. So the prompt shape for your Claude Code is going to look like this. Symptoms, reproduction, suspected files. Ask for diagnosis first. Ask for a fix second only after confidence. So an example Claude Code prompt is going to look like this. Investigate why order flow notifications look visually inconsistent from settings notifications. Find root cause across theme tokens, shared notification components, and platform-specific rendering. Give me the smallest safe fix plan first. Don't patch just yet. This is where Claude Code shines. All right. Now, here is the anti-limit doctrine, because I'm about efficiency, right? I want to get the most out of my tools. And so never spend frontier model turns on discovery. So you want to do repo discovery once and then save it. So for Codex, you want to use repo local guidance like agents.md and skills, so the tool stops relearning your preferences every session. OpenAI explicitly recommends repo policy in agents.md and repo local skills in .agents/skills to improve speed and accuracy on recurring work. So for Claude Code, use its skills, hooks, and auto memory so it preserves build commands, debugging learnings, and workflow conventions. So what to store? So you want to store how to run the app, how to run tests, lint type check commands, key directories, design rules, files, never to touch casually, platform gotchas, commit style, preferred debugging order. This alone is going to save you huge usage, which is going to save you huge time. Now, number 2, you want to split thinking from doing. So use one request to plan and then use one request to execute. Now, a bad example of this is going to be here's the prompt, right? So analyze the issue, propose architecture, compare options, update 8 files, run tests, and summarize trade-offs. So now a good example is going to be this. Step 1, diagnose and propose a smallest safe fix. Step 2, implement only approved fixes. Step 3, run the verification. Step 4, summarize diff and risk. This cuts retries and bloated output. All right. So you want to use, number 3, you want to use context like a sniper, not a fire hose. So you only want to include selected code, 1 to 3 relevant files, at the exact era, current behavior versus desired behavior. Do not dump the whole repo unless the problem truly spans the entire repo, right? Now, number 4, you want to give acceptance criteria every single time. Now, this is going to prevent wasteful rendering. So always include what success looks like, files that may be changed, files that must not be changed, and whether to patch now or only plan, whether UI only or logic is allowed, right? This is one I use a lot, right? Because when I'm touching UI only stuff, I don't want any logic to be changed, because sometimes LLMs can be very what's the word? They can touch logic without you meaning to touch any logic, and that can start to break infrastructure. Now, number 5, you want to default to the smallest viable model or task mode. For Codex, stay on a cheaper, smaller mode until the task proves it needs more. OpenAI's own product flow now nudges users towards Codex Mini near the limit for exactly this reason. For Cursor, be careful with this max mode, because Cursor documents that it takes token-based pricing at the model's API rate and adds a premium on individual plans. So Cursor also offers higher usage tiers like Pro Plus, Ultra, Max style usage behaviors that can burn usage much faster than normal defaults. So bluntly, max mode is for exceptional tasks, not your default personality, but I don't really use Cursor in this setup. Remember, Cursor is just the IDE. So I might use Cursor when maybe I want a breakdown of like the repo, or maybe I want, a README update or something very simple, but I really don't touch Cursor since I don't have a subscription there. I pay for Codex, I pay for Claude Code. So I'm mostly using Codex and Claude Code. Like I said, Cursor is just the IDE because it makes it a little bit easier for me to code in Cursor, since I've been coding inside of Cursor since it came out, essentially. Now, the best division of labor is going to be this here. So Codex jobs, implement feature from spec, create component page from screenshot, refactor one subsystem, write tests for change files, generate migration div, apply targeted fixes fast, parallelize independent tasks when needed. OpenAI's current Codex surfaces are explicitly built for parallel agents, work trees, local cloud handoff, and reusable skills. Now, these are the jobs you're going to use for Claude Code, right? Now, these are just examples. This isn't an exhaustive list, right? But this is sort of a base you can build off of. Now, Claude Code jobs: diagnose strange bugs, review Codex output before merge, find hidden regressions, trace data flow, inspect shell build test failures, compare implementation options, and enforce deterministic workflows with hooks. So Anthropic's docs specifically highlight hooks for deterministic behavior and skills for reusable workflows. So now here's the review loop that saves most usage. So use this exact sequence, right? This is exactly how I code. I use this exact workflow, right? With everything I'm giving you guys, I use this exactly. So number 1, Codex, implement narrowly. Number 2, with Claude Code, review for correctness, regressions, and missing edge cases. Number 3, Codex, apply only the approved review fixes. Number 4, with Claude Code, you want to do a final verification or terminal validation, right? This is much more efficient than having both generate competing implementations. Now, what to standardize in your repos? So you want to create these files one time, right? So agents.md. Now for Codex, this is going to have project overviews, run commands, test commands, architecture map, coding rules, safe edit zones, high risk zones, and preferred response format. So OpenAI specifically calls out agents.md and repo local skills as a way to improve recurring work. Now, Claude skills, you're going to create skills like fix UI regression, trace API flow, review PR, prep release, verify mobile web parity, right? So Claude Code supports custom skills via skill.md, and it can invoke them when relevant or directly by name. Then we get into Claude hooks. So use hooks to automatically run formatter after edits, lint changed files, type check, touch scope, block risky commands, log change files, review or generate review summary. Anthropic documents hooks as deterministic controls that run at a specific lifecycle points, exactly for enforcing rules and automation. Now, here are some prompt templates that waste the least usage. So, and like I said, if you're not using prompt templates right now, at the very least, you should be using prompt templates. I mean, you shouldn't just be prompt engineering is like, at this point, there are some people out there who have gotten their prompt engineering to a point where, they know exactly what they're doing, and maybe they have a system where they're using that to make money. So at this point, you need, and a lot of people aren't sharing that because, this is, like I said, this information is worth its weight in gold, especially if you have a system that works for you and that works well, depending on what you're doing. So you need to at least be using a template, all right, at the very least. So Codex build request. So use this template. So you want to give it a goal, scope, constraints, acceptance criteria, output, and verify, right? For Claude Code diagnosis, here's the template I use. Give it a symptom, expected or desired behavior, reproduction steps, suspected area, files or modules. Ask it to diagnose root cause first, then propose smaller safe fix. Do not patch until confidence is high. For Claude review of codex output, here, do you want to use this template? How to avoid blowing your 5-hour codex window. So OpenAI says Codex will offer GPT-5 Codex Mini when you hit 90% of your 5-hour usage limit. Use that behavior intentionally instead of treating it as a warning you failed. So the rule is this: first 70% of the window, serious implementation only. 70 to 90% equals smaller scoped fixes, review, and test. 90% mini model cleanup, docs, follow-up, patches, staging tasks. So near the edge, stop asking for architecture work and start using the cheaper lane. What to stop doing immediately: stop asking for best possible anything. Stop requesting giant plans plus code plus tests plus docs in one turn. Pasting huge logs without narrowing the ask. Asking both agents for the same implementation. Using expensive modes for cosmetic edits. Keeping chats alive forever with stale context. Old bloated threads cause drift and waits reset sooner. The mindset shift that matters most: don't think which model is the smartest. Think which model should spend tokens on this exact layer of the problem. So that is the whole game, right? Which model am I going to use for this problem, right? And then which model am I going to use when I go into debugging and tests? Which model am I going to use for simple cleanup and rearranging my files, right? My directory. So you want to be making the most usage of these LLMs, right? So you can be your most efficient. Now, this is my default workflow as I showed you guys before. So daily default, Cursor plus Codex for building, Claude Code only when blocked, reviewing, or debugging something weird. Then you have for UI work, Codex builds from screenshot spec, Claude reviews visual consistency and edge cases, Codex applies minimal patch. For backend bug, Claude diagnosis first, Codex patches second, Claude validates via terminal test flow. For repo maintenance, Codex handles repetitive batch work, Claude runs release review verification skills. The bottom line is, so it said my belief was mostly right. Limits are usually a workflow problem, because this is how I kind of started this conversation by telling ChatGPT that people reach limits because of how they're using LLMs, not because they're limited by the token allocation they're given. So the most efficient setup is not to ask better prompts. It's this: Codex builds, Claude diagnosis and reviews, skills and repo instructions eliminate repeated explanation, hooks automate verification, many cheat modes handle low value work, max frontier modes are reserved for high leverage tasks only. So that's how you stay fast, hit fewer limits, and get much more out of the same paid stack. Let's see. And yeah, guys, so maybe I'll share some more on this, right? Because I've expanded this into a whole entire system. Maybe I'll share that with you guys beyond just this video, right? If you guys want to. But I'll go ahead and leave it there. So let's talk about, I've been actually looking for a new content creation mic. So I was doing some research and I came across a few of them. I think I'm going to probably go with this Razer Seiren V3 mini microphone because I needed something that was under $50. So these are some of the best options for content creation microphones under $50. If you guys are interested, you have the Fifine T669 USB condenser mic for $50 at Micro Center. You have the One Audio wired over-the-ear microphones. These are $30. You have the Razer Seiren V3 mini microphone for $40 at Target. I'm probably going to go with this one, or the Kensington USB-C hi-fi mic headphones. You have the Zero Sound USB microphone and the Fifine K669 USB microphone. So I'm probably going to go, it's probably going to be the Razer, maybe this Fifine one too, but it'll likely be this Razer one because I like how it looks, or it'll be this Kensington Hi-Fi USB-C. And I'll show you guys because I was looking at this one already. This is probably the one I'm going to go with. They have it in white. I'll probably get it in black, or I'll probably get a pair of these because my current headphones, they're not doing the job. They're doing the job, but they're not the best. So I need to up my sound quality. So, but yeah, guys, I'll go ahead and wrap it up there. Thank you guys for tuning in to the live stream, and I'll see you guys in the next one. Yeah, why do they keep doing that? It makes it messes up my My thing when it does that messed up my